In today's class, we will solve a few problem sums based on real numbers, LCM and HCF, which are of level 1. So let's get started. The first problem sum says that what is the digit in tens place in the product of the first 35 even natural numbers. Now we know that 0 is also an even number, but here we will not start our counting from 0 as we are focusing on natural numbers. So here our counting will start from 2, and next we will consider 34 more even natural numbers. So if we arrange first 35 even natural numbers this way, in the first row we will consider first 5 even natural numbers from 2 to 10, and then from 12 to 20, and then definitely it will be from 22 to 30, and accordingly we will arrange other even natural numbers from 22 to 70. Now the first 5 even natural numbers that we have in the first row, if we multiply them, then the product will be 3840. And now if we multiply the next 5 even natural numbers from 12 to 20, then the product of that multiplication will be 967680. So what we can notice here is in the first multiplication result at units place we have 0, and in the second multiplication result at units place we have again 0. Now if we multiply these two values, then in that result of multiplication at units place and as well as at tens place, the digits that we will have will be both will be 0. And now if we proceed further, then for the third set of multiplication, as we have 30 here, so again in that multiplication result also at units place we will have 0, and for other sets also at units place that will be 0 only, the digit. And total we have here 7 sets. So if we multiply all these 35 even natural numbers, then not only at units place or tens place, but also till 7th place from units place the digit will be 0. So here we don't have to proceed further since we have already obtained the value at tens place. So we can conclude here itself that the digit at tens place in that multiplication will be 0. Now the second problem sum says 73412130, that given number is exactly divisible by which of these options. Now the divisibility rule for 3 and 9 both are same. So if the summation of all the digits that are there in the given number, if that is divisible by 3, then the whole given number will be divisible by 3, and if that is divisible by 9, that summation, then the given number will be divisible by 9. We know that rule. So let's first do the summation. So here the summation of all the digits in that given number is 21, which is divisible by 3. So that number will be divisible by 3, but this is not divisible by 9. So that number will not be divisible by 9. And let's check for other two given options. Now for 11 we know if the summation of the digits that we have at even places and if the summation of the digits that we have at the odd places, if the difference of those two summations is 0 or divisible by 11, then that given number will be divisible by 11. So here the summation of all the digits that we have at even places, that is 16, and for odd places that summation is 5. And if we take the difference, then that result of subtraction is 11, which is 11 itself, so that is divisible by 11. That means that given number will be divisible by 11. Now let's check for 7. So for 7, what we do, we take the digit that we have at extreme right, means at units place, and then we multiply that digit by 2. So for 0 it will be 0 only, and then we discard that digit from the number, and then we subtract the result of multiplication from the rest of the number. So here the result is 0. So if we subtract that, then it will be that number itself that we had after discarding the digit at units place. Now what we will do, we will repeat the same process. So now we have 3 at units place. So we will multiply 3 by 2. So it will give us 6. Then we will discard 3, and then we will subtract 6 from rest of the number. So the result of subtraction will be 7 3 4 1. Then here we will have 15. Then what we will do, again we will repeat the process. So here this time 5 will be multiplied by 2, so that will give us 10. And what we will do next, we will discard 5, and from rest of the number we will subtract 10. So that will give us 7 3 4, and here we will have 0 1. Then you can understand what we will do next. We will take 1 and then we will multiply by 2, so that will give us 2. We will discard this time 1, and from 7340 we will subtract 2, and whatever number we will get, then we will repeat the same process until we obtain a two-digit number where we can easily understand or conclude whether that number is divisible by 7 or not. If that two-digit number or the final number that we are getting by following this process, if that number is 0 or divisible by 7, then the whole given number will be divisible by 7. Now if you complete this process, then finally the number that we will get, you will see that that number is neither 0 nor divisible by 7. So this option is not correct. And here we are doing this division by all these options by applying the rules of divisibility that we know, that we have studied. Here we are not doing the real division. So for this question, the correct options are option A and D. Now we will move on to the next question. The next problem sum says that find the units digit in the product of the first 50 odd natural numbers. Now here again natural numbers and odd natural number this time. That means our counting will start from 1 and it will continue till for next 49 odd natural numbers. So again, if we arrange all our 50 odd natural numbers in some sets, then in each set we will have 5 odd natural numbers. So if we consider the first set and if we do the multiplication, then in the result of multiplication, which is 945, at units place the digit will be 5 as we are multiplying by 5. And interestingly, if we multiply the next set, that where also we have 5 odd natural numbers, there also we have 15. And 15 means at units place in 15 again we have 5. So whatever will be the result of multiplication here, at units place of that multiplication again we will have 5. And accordingly, if we complete all other multiplication for all other sets, everywhere we will see that in the result of multiplication at units place we will have 5 only. Now if we multiply all these results of multiplication, which will be the multiplication result of 50 odd natural numbers, as in every set we have 5 at units place, so in the final result also whatever will be the value, we don't bother, at units place it will be 5 only. And that's what was expected from us, that find the units digit, means the digit at units place in the product. So without doing the real multiplication, without knowing the real value, final value, we can conclude or we can answer. Now the next question asks that how many composite numbers are there in between 50 and 100, inclusive 50 and 100. So inclusive 50 and 100 means if we count total numbers that we have within that range, then it will be total 51. Now we need to find the total composite numbers. Now composite numbers, we know that the number which has at least 3 factors. So between 50 and 100, within that range, all the even numbers will be at least divisible by 2. So third factor will be 2, and that could be divisible by other numbers also. But at least all the even numbers are composite numbers. So here the list will be more. If we count the composite numbers, the list will be more, as all the even numbers will be composite numbers, and then from the rest of the odd numbers also, some of them will be composite numbers, like 55. If we take 55 is divisible by 5 and also divisible by 11, so that will be composite number. But what we can do is, to save time, if we count the total number of prime numbers from that list, from that range, and then if we subtract from 51, then that will be the count of the total composite numbers, right? So what we will do here is, we will count the total prime numbers. And to do that, what we have done here is we have considered only the odd numbers. So I have written all the odd numbers from 51 to 99 within that range. Now 51 is divisible by 3. We know 5 plus 1 it is 6, so that is divisible by 3. That is a composite number. 53 is a odd number. 55 again composite number, and 59 is a prime number. Similarly, if we go by the same process, so in total we have here 10 prime numbers. So total numbers within that range is 51 and total prime numbers is 10. That means total composite number in that range will be 41. Now the next problem sum says that what is the number in the units place of 763 to the power 84. Now by looking at the power, the value that we have in the power, it looks like a big problem which may take more time, but it is not if we apply this trick. Like 763, when it will be multiplied by another 763. So we are here focusing on the digit that we have at units place. So we will focus on that only, not the real value of the multiplication. So at units place, what we have here, 3 and 3. So if we multiply 3 and 3, we know that result will be 9. Now if we multiply by another 63 means in this product at units place we have 9. So with that 9, if we multiply, this unit digit here also we have 3, so it will be 27. So at units place what we have, 7. Now with that 7 and with this multiplication, if we multiply another 763, that means at units place again we have 3, and here till third number here at units place in the multiplication we have 7. So 7 when will be multiplied by 3, it will be 21. So at units place we have 21. Now if we multiply by the fifth digit, so again 3, so here it will be 1 will be multiplied by 3, so at units place again we will have 3. And so this way if we continue, if we multiply by another 763, here again this 3 and this 3, if we multiply, then again we will have 9, and definitely it will be at units place. So 9 means again we have got back this digit 9. So with 9 again if we multiply 3, so we'll get 27, means at units place it will be 7, and this set will be repeated from 9 to again this 3. So we don't need to check till 84th digit. We don't need to do all the multiplication because we have already formed, or we have already come to know the pattern what digit we will have at units place after multiplication of each set or pattern. Now 84, that we know that is 4 multiplied by 21. That means we can say that 84 is a multiple of 4. Whatever will be the digit at units place in the result of multiplication till fourth digit, the same digit we will be getting at units place after multiplication of 84 numbers, means 84 763. So what we have to check here is after multiplication of 4 763, what is the digit at units place. So here 3 multiplied by 3, 9. So 2 763, here third, this is the fourth. So this says that after multiplication of this 4 763 in the result, the value we don't know, but at least we know in that result at units place the digit will be 1. Then after multiplication of 84 763, that number, there also in that result at units place the value will be 1. So the correct option is option A. Now the next problem sum says the HCF of all the natural numbers from 200 to 478. HCF, highest common factor. Now from 200 to 478, that range is also big range. We have total 278 plus 1, 279 numbers. Now among those 279 numbers, there will be some even numbers which are composite numbers, and some of the numbers will be odd numbers, and from those odd numbers some of them will be prime numbers also. and those prime numbers will not be multiple to each other. So if we consider all these numbers from 200 to 478, then other than 1 there will be no common factor. So if there is only one common factor, which is 1, so that will be the highest only. So here the answer will be the HCF highest common factor is 1. The next one says the sum of the numbers from 1 to 20, and we have to choose from the given options. So from 1 to 20, if we arrange this way, then what we can see here is in the first set, in the first row, we have 10 numbers from 1 to 10, and among these 10 numbers we have 5 odd numbers and 5 even numbers, and the summation of all the even numbers is always even, and that will be whole number as well. And if the summation is even number, then that will never be prime number. So we have to focus on the summation of the odd numbers. Now here if we add all the odd numbers in the first row, what we can notice here that 1 plus 3, the result is 4, so that is even number. Then 4 plus 9, that result is 9, so that is odd number. That means when we add two odd numbers, that results even number, and when we add three odd numbers, then that results odd number. So here we have 5 odd numbers. That means the result of addition of all these 5 odd numbers will be odd, and that value is 25. So here it is odd number, and again in the second row again we have 5 odd numbers. So whatever will be the result of summation, but that result will be definitely a odd number, and that is 75. And when we will add these two odd numbers, definitely that will be even number as we know, and that value is 100. So the summation of all the numbers from 1 to 20 will be even, so that will never be odd, and if it is even, then that will not be prime number. And since it is an even number, so apart from even number, that value will be also whole number, as we are adding whole numbers only. Now the next problem sum says if the numbers m minus n and m plus n are twin primes, then m and n are necessarily, means we have to find the relationship between m and n. So twin primes, we know if the difference of two prime numbers is 2, then those two prime numbers are called twin primes. So here one of the numbers is m plus n and the other number is m minus n, and when we will take the difference, as they are twin primes, so that difference will be 2. So if we simplify further, n will be 1. So if we choose any value for m for which m minus n and m plus n both will be prime numbers, we know 41 and 43, these two are prime numbers and their difference is 2. So value of m for them will be 42. Now m minus n, 42 minus 1, it will be 41, and m plus n, 42 plus 1, it will be 43. So m and n, between m and n means between 42 and 1, if we develop the relationship, what we can see here, they will have only one common factor. As always the value of n is 1, so they will always have one common factor, which is 1. And if between two numbers, if there is only one common factor, which is 1, then those two numbers are called co-primes. Now if we move on to the next problem sum, it says find the greatest number that divides 59 and 54, leaving remainders 3 and 5 respectively. That means the greatest number that we need to find, if we divide by that number 59 and 54, there will be still, they will not be completely divisible, they will leave some remainders. So at the beginning, if we subtract those remainders, then the numbers that we will get, those numbers will be completely divisible by the greatest number that we are supposed to find. Now this 56 and 49 will be completely divisible by the greatest number that we are supposed to find. So here this greatest number basically will be the common number or common factor which can divide completely these two numbers. So basically what we are finding here is greatest common divisor, or we can say highest common factor. So here we just have to do the HCF, or we have to find the highest common factor of these two numbers. So between 56 and 49, the greatest common divisor is 7. So for us, The correct option will be 7. Now the next problem sum says the find the units digit, means digit at units place in the expansion of this series sum. So here we have three numbers, 44 to the power 44, 55, again what we can see here. Now if we consider the middle term first, so 55 and also its power is 55. So if we multiply first two numbers, means first to 55, then what we can conclude here, whatever will be the result of multiplication at units place, the digit will be 5. So now this way if we continue the whole multiplication for 55 terms, at units place the digit will be 5. Now let's focus on 44 and 88, those two terms. So the first term is 44 to the power 44 and the third term is 88 to the power 88. Now if we multiply first to 44, as we are focusing on the digit of units place only, so what we will do is, again this type of problem we have already solved, we will take the multiplication of the digits that we have at units place only. So this time it will be 16. Now we will consider the digit that we have at units place in that multiplication. So it will be 6, and then now if we multiply by the third 44, so again we will take the 4 as we did for the first two terms or first two numbers. So 4, then when 6 will be multiplied by 4, the result will be 24. So definitely at units place, when we will multiply this 344 at units place in that result of multiplication, the digit will be 4. Now if we multiply by another 44, so again 4 at units place, so from here we will take 4 and we will multiply by that 4, then it will be 16. So again at units place what we are getting is 6. Now again if we multiply by another 44, which is the fifth 44, so it will be 6 multiplied by 4, so that will be 24. So at units place it will be 4. So we have already formed a pattern. We have noticed that here when we are multiplying first two 44s at units place, the digit is 6, then the digit is 4 when we are doing for third 44 or the odd number of 44, then again for even number of 44 again the digit is 6, and then again 4, and this way it will continue. So we have to see what is the power is 44. So 44 is even number, and what we have noticed here, that when we are multiplying even number of 44s at units place, the digit is 6. So 44 is even. So without knowing the real value of that multiplication, at least we can say, at least we can conclude that finally at units place the digit will be 6. Now let's evaluate for 88. Now 88, first to 88 when they will be multiplied. Now if we consider only the digits at units place, so 8 multiplied by 8, it will be 64. Fine. Now we will take the digit at units place, so 4, and then if we multiply by the third 88, we will take the digit at units place, so it will be 8, so it will be 32. So this time it will be 2. Now we will take 2, and if we multiply by another 88, so this time it will be 16. 6. Fine. Still now we have not formed or noticed any pattern. Now 6 and then another 88, so it is 6th or 5th 88. So this time again by 8, if we multiply it will be 48. Then if we take 8 again, then 8, then it will be 64. Then again 4 multiplied by 8, it will be 32. Now we have already, this pattern is getting repeated, so we have formed a pattern: 64, 32, 16, 48. Now if we continue our multiplication further, then again it is going to be 16 and 48 only. So here when we are multiplying first to 88, the digit at the units place in that multiplication result is 4. When third 88, it is 2. When fourth, then 16, and when fifth, then again 48, and so on. So here the power is what? Power is 88, and 88 is what? 88 is 4 multiplied by 22. So it is a multiple of 4. So what we have to focus is that after multiplication of 4 numbers, 4 88 or 888, what is the digit at units place in that result of multiplication? So we can say at the end of this multiplication, the digit at units place, it will be 6 only. So our question was find the units digit in this expansion. So 44 to the power 44, for that the digit at units place was 6, and for 55, for that term we have seen that digit is 5, and for 88, the third term, that digit also we have found at units place 6. So now if we add these 3, so it will be 17. So 17 means we have to focus on what is the digit at units place. So digit is 7. So here the correct option will be 7. So for this type of expansion or for this type of series sum, this is one of the ways how we can solve, or this is one of the tricks what we can apply. So I hope this class was meaningful and helpful for you. With that hope, I end today's class. Thank you.